Have you ever trained a machine learning model that achieved 99% accuracy and felt incredibly proud? It looked perfect. The validation metrics were amazing. The graphs looked beautiful. Everything suggested your model was brilliant. But then, something strange happened. You deployed the model into the real world, and suddenly it performed terribly. Predictions were wrong, accuracy collapsed, and the model that once looked like a genius suddenly behaved like a beginner. What happened? In many cases, the answer is simple. Your model was cheating. Not intentionally, of course, but the data allowed it to see information it should never have seen. This problem is called feature leakage, also known as data leakage, and it is one of the most common mistakes in machine learning. To understand feature leakage, imagine you are trying to predict whether a student will pass an exam. You collect a dataset with many features: hours studied, attendance, homework scores, sleep time. These are all reasonable features, but imagine you accidentally include one more feature: final exam score. Now think about what happens. Your model will become incredibly accurate. It will quickly learn that a high exam score means the student passed. Accuracy might jump to 99% or even 100%. But the model didn't actually learn anything useful. It simply saw the answer hidden in the data. This is feature leakage. The model learns patterns that would not exist in the real world at prediction time. In other words, the model has access to future information, and that creates a dangerous illusion. Because during training, everything looks perfect. Metrics look fantastic. But when the model goes into production, that leaked information no longer exists. So the model suddenly loses its advantage, and performance collapses. This is why many machine learning models look amazing during development, but fail in production. Feature leakage can happen in many subtle ways. For example, imagine a hospital model that predicts whether a patient will develop a serious condition. Suppose the dataset includes a feature called medication prescribed. But doctors only prescribe that medication after diagnosing the disease. Now the model can simply learn medication prescribed equals disease present. Again, accuracy becomes extremely high, but the model is useless. Because when you try to predict the disease earlier, the medication hasn't been prescribed yet. So the model was never actually predicting the disease. It was just detecting the result of the diagnosis. Another common example happens with time leakage. Suppose you are building a model to predict whether a customer will cancel a subscription. Your data set contains activity logs. But some of those logs occur after the cancellation date. For instance, account closure events, support tickets complaining about cancellation. If those future signals enter the training data, the model learns from information that should not exist yet. Again, accuracy becomes misleadingly high. The model appears powerful, but in reality, it is cheating. Feature leakage is dangerous because it hides inside good metrics. The numbers look convincing. Accuracy rises. Loss decreases. Everything suggests success. But the model has learned shortcuts instead of real patterns. So, how do experienced machine learning engineers avoid this problem? First, always ask a simple question. Would this feature exist at the moment we make a prediction? If the answer is no, that feature should not be used. Second, be extremely careful with time-based data. When working with real-world systems like finance, healthcare, or user behavior, time order matters. Training data must only include information available before the prediction moment. Third, Separate data preparation carefully. Sometimes leakage happens when pre-processing steps accidentally use the entire dataset. For example, computing statistics across both training and test data. This leaks information from the test set into training. Instead, transformations should be learned only from the training data. Finally, always be suspicious of results that seem too good to be true. If a complex, real-world problem suddenly produces 99% accuracy, something might be wrong. It could be overfitting, or it could be feature leakage. In fact, many experienced machine learning engineers say this: if your model suddenly looks perfect, your first instinct should be to look for leakage. Because in real machine learning systems, perfect accuracy is rare. The good news is that once you understand feature leakage, it becomes much easier to avoid. And learning to detect it is one of the skills that separates beginners from professional machine learning engineers. So the next time your model produces incredible results, pause for a moment. Ask yourself one important question: is my model actually intelligent?